Okay, so what I'm going to try and demonstrate in this video is the relative performance of querying data from one table that has lots of records versus a table that doesn't have many records. And this is to simulate the proposal of creating that second table based on the patient deceased table that we were going to create, rather than creating just another field within the patient table. So what I've got here is I've got two patient table setups. The first one, which is denoted by patient 1, so I'm using my setup here is I've got my SQL server running locally on my machine, and I'm using an application called SQL Pro as the client for MySQL, and then I'm going to use a combination of PHP scripts being run from Bash to basically populate that database with a load of data, and then I'm just going to run a few queries, or a couple of queries from SQL Pro, just to demonstrate how long particular queries take to run. But the first thing I can do is I can show you the tables listed in the database here. The first table, patient 1, just has three fields: ID, name, and address. ID is an auto-incrementing primary key field. It has no other indexes. Patient 2 is similar, but it only has one field, and that's name. Whereas patient 1 has got name and address. Patient 2 just has name. And that has an ID, which is also an auto-incrementing primary key field. What we have here is patient 2 address, which, similar, I think, to the structure that was being proposed earlier, has an ID field, which is auto-incrementing. In this case, I've moved the address, effectively, the address field that should be in the patient table, in my example, we've moved to a separate table, and I've then basically set up patient ID essentially as a foreign key. I've not got anything on there which is actually linking it back to the patient 1 table, but it's there essentially to be the foreign key. All of the text fields there allow null values as is the patient ID. So 3 empty tables, nothing in them. They're just structures at the moment. And I say there's one index on each table, and that's the primary index on the ID field. What I've then got here is a PHP script that just simply it's got some database credentials. It's got a little connection string. I've got a num-patients field here, which just basically will set up this number of records. I then got 3 queries which just empty the database, and I've then got a little for loop that just runs round for the number of patients that I want to create. It generates a random name, a random address. It inserts the name and address into patient 1 table, then it inserts the name into the patient 2 table, and then basically it's got this little if statement here which just effectively says 10% of the time we're going to insert an address. So this mimics the structure that we were talking about earlier, where we're saying there will be less values in that table, in that second table, and therefore querying that table will be faster than querying the main patient table, and therefore that's an argument for creating a second table rather than having that field as a field within the main patient table. So we'll see here when I go through this. So if that's at 10,000, then effectively what will happen here is we'll end up with 10,000 records in patient 1, 10,000 records in patient 2, and about 1,000 records in patient 2 address. It's not exact because it's using a random number and it's just basically randomly picking that, but broadly speaking, it'll come out at about 10%. So just to make this slightly kind of more realistic, what I'm going to do is just put it up to 1 million so that it really does kind of exaggerate our queries a little bit. So that does mean that when I run this script here, that's just going to take a little while to run. I guess it might take I guess it might take up to Okay, so that's now completed. So now we can go back to SQL Pro. We can go to the content there and we can see, if I just refresh that, so we've got actually just under, for whatever reason, well, in fact no, it's saying about, we've got about 1 million records. I guess we should have 1 million records in there, so we should be able to do select count start from patient 1. Yeah, so we've got 1 million records in there. We can see how many we've got. We have about 100,000 in patient 2 address, and we have 1 million in patient 2. So we've got 1 million records in patient 1, we've got 1 million records in patient 2, and we've got just over 100,000 in patient 2 address. So first thing I need to do is get an address out of patient 2. So let me go, let's go towards this. Let's take that address there. Go back to our query. Let's put that in there. So what I've got here is two queries. One which is going to patient 1 and is going to search for that address. It's going to find that record. And the second one is just going to do the same search against patient 2 address. So this is, essentially what would happen if we're saying, query against a table that's just got a couple of fields in it, that's kind of keeping things small, versus a table where we've got all the fields in there and lots of records. So as things are, we can wonder what would happen if we search against patient 1, run that. So that's pulled out the record, and that's taken 194 milliseconds. So not massively slow, but it's still taken a while. So that's not going to work, is it? There you go. So let's try patient 2 address. So we'll run that, and that's taken 19.1 milliseconds. And let's just kind of check that for consistency. If I run that again, in fact, actually, it's kind of much faster. Oh no, sorry, so that's actually point one of a milli. That's but that's coming out at 0.1 millisecond there. That one is coming out at. That's now coming out at 20. So actually, both of them have kind of come right down. But still, we can see that 20 milliseconds versus 0.1, 0.2 milliseconds. Scale that up to lots and lots of queries going into the database. Something which is of the magnitude of 200 times slower, to do against the patient 1 table. You think, well, maybe that kind of makes this worthwhile doing. If that's going to be like that, but it's not the whole picture there, because I think we can go into the patient 1 table here. If we know we're going to be searching on something, we know we're going to be searching on the index, then we can just set up an index for that. And we can also go into the patient 2 address and similarly add the address index there. That's already on address, so that's okay. So we've now got an index on the patient 1 table for address and also on patient 2 address. So we can see now what impact that has on these queries. So on that second one, on the one which we expect to be fast anyway, actually, I'm being an idiot. I tell you, I'm such a doofus. Let me go back to that. I wasn't doing that correctly then. think I was executing the comment rather than the query. So let's just do that again. This one, run that. 189 milliseconds. Right, 100. That's better. I don't know why it's kind of suddenly going so fast. 19. So that's 20 milliseconds. 20 milliseconds. So it's still okay. So the first one. There we go. That's selected it. First one, 189 to 200 milliseconds, 200 milliseconds. So let's call that. Just call that for argument's sake 200. And then this one, when we run it, is constantly about sort of 19, 18, 19, 20. So actually, we can say it's 10 times faster, which actually makes sense. It's got 10 times as many records. It takes 10 times as long. Common sense prevails. So let's go back and add our indexes. Okay, so we've got address index on address, and we've got wrong column. Okay, so we've now got an index on address, and we've got an index on address. So now the question is if it took 200 milliseconds for patient 1 to query that table for that record without an index, and it took 20 milliseconds to query this table without an index, what's going to be the impact second time around? So let's go with our patient 2 address. So the one that was, much faster before, 20 milliseconds. What is it now? 0.4 of a millisecond. So before was 20 milliseconds, and after is 0.4 of a millisecond. So that's pretty damn good. What about the first one, the one which we expect to be slow? Run that, 0.4, that's 0.3, 0.4, 0.6, 0.3, 4. So that's also about 0.4 milliseconds. Let's just run this again just to see if it's, that's pretty much. So without an index, there is a kind of a clear performance advantage querying against a table that has got less rows in it. And it is proportional to the number of rows in there. So we can see the table with 10 times as many records takes 10 times as long to find a record in there, as you would expect. But when you then place an index on those tables for the column you want to query on, both tables become lightning fast. So this is what thinking about it kind of from a common sense perspective, it would make sense that this is the case. Otherwise, where's the incentive to structure your data where a table represents all of the properties, all of the kind of the attributes of your object. You'd start to say, well, actually, I've got too many fields in this table. I will now start arbitrarily, splitting them out into separate tables, even though there's a one-to-one relationship between them. I'm going to start arbitrarily splitting them out just for performance reasons. And that would then bring in significant. It would start to confuse things, because you've got. When someone looks at a database and they look at a table, it's reasonable to expect that when you design a database, tables will be, there will be some relationship between your logical data model and the tables that are being used to store the data. It's not always the case. There are times when that isn't the case, and it depends on what you're doing. So with the content management system, quite often, if you look at something like Drupal, the underlying schema does not represent your application's data model. We've just obviously implemented a search index. The search index doesn't represent the data model. But in terms of the actual kind of the core part of the database, you want that to represent, to be as close as possible to the logical data structures within the application as possible, because it just makes things simpler. And unless there is some problem you're trying to overcome, it's probably best to keep it as close to that as possible. And most database systems will give you the tools to be able to do that. And obviously, hopefully I've shown here that just by the application of a couple of indexes, we can demonstrate that even with a million rows in there, the performance is just as fast whether you've got the fields in one table or in two tables. And that being the case, the simpler of the two solutions, i.e. having the fields in one table where they logically make sense to be together, why would you not do it? Hopefully that's kind of given some hopefully that's kind of helped in terms of explaining and justifying why we are better off keeping the fields in one table, and why performance won't be, or at least to say, there is nothing in the way SQL Server works that means it will penalise you for putting the fields in one table. We may not use the tools correctly, but SQL Server can provide what we need, and it will not lose performance if configured correctly. Hope that helps.